grid view?
Lord,
The YouTube.
Right, I switched it for a minute.
Okay.
Let me switch it back.
And I see a lot of people joining, so thanks for joining. Hopefully you saw the schedule. We'll be kicking off we've already kicked off our GitOps Days community special, which we've now wrapped together with our usual Weave online user group that runs on Tuesdays. Today we moved it to Wednesday to incorporate this all together. So the first 30 minutes is sort of our GitOps Days usual kind of AV check where we invite you guys to join. And obviously you guys have given us great feedback. That's exactly what we need. And just chatting, just hearing where people are coming from, what kind of questions you might have specifically for Alex talk, and then later we'll have Javeria, but coming up is Alex. And we just discussed that we'll probably do questions at the end, so please, feel free to put them in the chat box and we'll address them. And then also I was talking on a bigger picture. So this GitOps Days community special is a weekly event that we're putting on mostly to test the different platforms, as you can see, and seeing what works and getting people's feedback. But it's leading up to an official GitOps Days event, which is May 20th and 21st. So we'll be sharing the link to that once we get the website up in the next couple of days. And I would love to see you there. We're really excited. Some of the confirmed speakers are probably the most important one is Kelsey Hightower. Really excited that he'll be joining and giving his thoughts. And we always love seeing him do live demos. So he's already agreed to take on some ideas. We have our fairly new CTO at Weaveworks, Cornelia Davis, who's come over from Pivotal. And she's really been heads down at getting onboarded and seeing the landscape. And I feel has a really great way of articulating where GitOps can grow to next, really is the next part of its evolution. So if people have understood GitOps to be within a particular space, most often CI/CD, there's so many more layers to that. And there are some people already practicing that. So we've been working with some speakers to share their stories as well. But if you're looking for any particular content for what you would consider a GitOps event, what would make it successful for you, then please feel free to put stuff in the chat, or we'll be following up with an email if you've joined by Zoom, and you can email me directly with your thoughts. We've also created an alias called GitOps@weave.works, so you can definitely send any thoughts or questions there. So with that, why don't we officially get started with our Weave online user group. Javeria, if you want to get off camera, you can go get some coffee and take a rest. We'll have Alex do his talk, and then we'll reach out to you, depending on how long the Q&A goes. So usually these things last about 45 minutes, but if they're burning questions, then we usually go to have a hard stop at the end of the hour. So we'll see how things go. If you've joined our GitOps Days community special in the last couple of iterations, we've had Daniel Holbach, one of our community managers, DJing during some of the breaks, which has been really fun. Of course, it's very late for him in Berlin time today, so we have some nice pre-recorded music that he's provided for us. So we'll have those during the breaks. So with that, give me 1 second. I need to pull up my slide. Major slides. Yes. So I'm going to shift gears a little bit and go into Weave online user group mode. And so can you guys see my slides?
Yeah.
Yes, excellent. So as I mentioned, if you've joined our GitOps Day special, and I'm going to shift a little bit into our format, which is our usual Weave online user group talks. Stacy here is our one of our community managers, and thanks to her, we've got these great series of talks that we do every 2 weeks. And we're very fortunate today to have Alex Ellis, that hopefully many of you know as a creator of OpenFaaS, and it worked out perfectly that he'll be talking about GitOps meets serverless with OpenFaaS. And hopefully you guys know the open source project that we started, Flux, which is now in the CNCF. So he'll be talking about that. So before we get into that, I'll just do a brief explanation. So Stacy and I mentioned Daniel Holbach. People work on Flux include Stefan Prodon, who has worked closely with Alex. We all work for a company called Weaveworks. We're a startup based in London, San Francisco, New York, Colorado, and Berlin, as well as distributed teams. If you've heard of the technology RabbitMQ, I mention it because our founding CTO and CEO were the people who created both the technology and the company RabbitMQ before selling it to VMware. And then fast forward, they started noticing needs in the container space, the developing Kubernetes space, and started building projects that then ended up leading to products and our company Weaveworks. We're a VC-funded startup by several, like Accel Partners. One of our funders is also Google Ventures, which I mentioned just to show yet another layer of our commitment to the Kubernetes space. If you know Weaveworks, you may know us from the many open source projects that we've founded. We have even more than can fit on this slide. A lot of you may know WeaveNet, which is still one of the premier projects to network your Kubernetes clusters. As we mentioned, Flux is really the project for automated deployments that led to the concept and term GitOps, which our CEO coined. Another is Cortex. That's both of those are in the CNCF as sandbox projects, and Cortex builds upon and extends the capabilities of Prometheus. And we mentioned Stefan working closely with Stefan Prodden on our team, working closely with Alex. Stefan is also the creator of Weave Flagger, which helps you do things like canary deployments in a particularly Kubernetes friendly way, or Kubernetes based way, should we say, and many more that were listed here. If you want to check out any of these projects, we have a GitHub page, so that's the best place to get started. We also do have products, and the main ones are Weave Cloud, which is a SaaS product that helps you manage, monitor, and do automated deployments for your Kubernetes clusters. In some ways, it's a hosted version of some of the other open source components that we mentioned. And of course, they have a UI and are well integrated with each other. In particular, it's important to think about using Prometheus metrics to do your automated deployments with Flux. What's interesting about Weave Cloud is it's on Kubernetes on AWS, and we've been running that in production for over 4 years now. So having over 4 years of Kubernetes in production experience has obviously made us really attractive to some customers. And so they asked, well, beyond just this SaaS product, is there more that you can offer? So we've been heads down and spent about the last year plus productizing the layer that we created to put Weave Cloud on AWS. And so now that's been productized as the Weave Kubernetes platform. And of course, because GitOps is so important, we made it a very GitOps aware enterprise platform. And so you can do that on-prem, you can do that in the cloud. And then on top of that, yes, we do offer some consulting training support to get people started. So if you're interested in any of this, if you're looking for if you're looking to do GitOps in a very enterprise way, come chat with us and we can help you get more information about that. So if this is your first time here, welcome. Our website is weave.works, and you can check out this information. So thanks for listening to that. So now we'll have a little bit of housekeeping. Again, as I mentioned, we are very fortunate today to have Alex Ellis, founder of OpenFaaS and creator of OpenFaaS, speaking about GitOps meeting serverless using that technology with Flux. If you've come to our Weave online user groups before, these usually last about 45 minutes. We've had some short ones at 30, but they usually go about 45, including Q&A. And if people really have lots of questions, then we do go to 60 minutes, but then we have a hard stop at the end. And as I mentioned, we've combined our Weave online user group with our GitOps Days community special. So we'll be going on until noon Pacific time. And after that, we have Javeria from Palo Alto Networks who will be joining us in conversation with Lee. Lee Capilli is one of our dev advocates in the Weaveworks team as well. So we'll be following it up with that conversation. So if you'd like to stick around afterwards, then you are free to join. We'll have some great information from Javeria. So really looking forward to that. Again, final housekeeping. I think most of you know Zoom at this point. If you have questions, please use the chat box. If you can't find the button, usually hitting escape gets you out of full screen mode. And when you do chat, please make sure you do it to all panelists and attendees. If you just send it to panelists, then people can't see your questions. And sometimes people answer each other's questions. So that makes it helpful. So please make sure you choose that in the drop down. For the GitOps Days portion, for those of you who are joining on YouTube, I'm seeing more and more people. I'm looking over here because I'm looking at my YouTube screen. Thanks for joining us. And yes, please put your questions in the stream and we'll do our best to monitor both and address them in the conversations. Again, I know these are difficult times going through COVID, so we really appreciate your joining us and we love to hear from you and hopefully provide very helpful information for you. So if this is your first time joining us, welcome. And if you're returnees, I do see some names. It's great to see you again. So with that, I will hand it over to Alex.
Thank you, Tamal.
Let me know if you need me to stop sharing first.
I would, yeah.
Okay, stop.
There we are.
Stop sharing.
So, hi everybody. We'll just get started here and make sure that you can see everything. So today, the sort of goals of this session are really to talk about what happens when GitOps and serverless meet. And because we're looking at tooling like Flux and OpenFaaS and Kubernetes, this isn't going to be the serverless that your grandma knew. I would refer to that as serverless 1.0. So your Amazon Lambda, your Azure functions, they kind of fit in that category. Serverless 2.0 is a bit different, and we'll see a landscape that we've put together, a bit like the CNCF landscape. We'll touch on OpenFaaS, what it can do for you, and how is that different from Kubernetes deployments and managing tons of YAML files. Then we're going to shift gears a bit and look at continuous deployment. There's two options here that are quite compelling: OpenFaaS Cloud and Flux from Weaveworks. That's now a CNCF project. And if you want to tweet at OpenFaaS or at Alex Ellis UK down there. So I'm going to start a timer, and I think we should be well within time. If you've got questions, drop them into the Zoom or the YouTube, and we'll pick them up at the end. So when we look at serverless and FaaS, and when I looked at this in 2016, I didn't actually know what the difference was, and it's probably fair to say many people don't know. But when we're talking about these ideas, what we're looking at is maybe a bit of a continuum. I've put this chart together. You can see in the top left, we've got a monolithic application, which is probably very large, lots of responsibilities, lots of complexity. And as you go up, you're getting more. So the functions are lower down because they're smaller, they do less things. As we move over to the right-hand side, there's even less concern for the infrastructure that that app is being deployed to. So that monolithic application, you probably used to deploy it to a bare metal server that you had to rack and plug in. Maybe even had to worry about the MAC address of the Ethernet adapter and things like that. Microservices really sort of came into bloom when Docker was popular in containers and ECS. And there we have fewer responsibilities, but more of them. And as you can see right over there with functions, they're smaller, but there's a load of them. And that's important actually, because they need to be easy to manage because we've got so many. Why are they easy to manage? Well, they tend to be stateless. They'll keep their state somewhere else, such as in a S3 bucket, maybe in a Git repo, maybe in MySQL, and there won't be much state in memory, maybe a connection pool. They're isomorphic, which means they all basically have the same shape. So it's not like a square peg in a round hole, it's a square peg in any square hole. And so when we look at a function, we probably have any number of them, but they can all be scaled up and down the same way. They can all have metrics recorded about them in the same way. And that makes it a bit easier to manage. Now, you'll typically look at this and maybe your first interaction will be through REST, right? A normal API. But event-driven is also really valid and popular way of using functions. Event-driven simply means that it's asynchronous, and maybe there's a different event source than a web service or web call that fired it off. And they are smaller, and smaller things tend to be easier to manage. And even though we've got a lot of them, they're easier because of these properties. If we took the properties away, we'd probably just have lots of monoliths and be back where we were again. And now the other thing that teams tend to like about this, and OpenFaaS users in particular, we hear this, is that they get to focus on the code. Daniel Mangum of Crossplane did a video conference with us, and he wanted to show Crossplane working with OpenFaaS. He made this comment: OpenFaaS is the easiest way to get an API working on Kubernetes. And I thought that was really sort of hitting the nail on the head. Now, that original serverless from way back 2013, 14, 15 looked a bit like this on the left, where if you were an Amazon customer, you would be deploying to Lambda in a zip file in a specific kind of format, using a specific kind of handler. And you would be limited to regions that were enabled by AWS. You would have to set up your IAM profiles. You'd have to potentially do VPC peering, and then suffer different cold start timings. If you wanted to move to GCP, well, all the regions are probably different. All the constraints of maximum file sizes and payloads are different. Actually, it's quite difficult to move, despite some efforts from Serverless Inc. to make a JavaScript CLI around this. Now, when you come to the enterprise, really, everything can't be run as functions. There are microservices too. People are very used to Spring, Express.js, Vertex, and we really need something that's portable, right? We can't rely on a SaaS product all the time. And that's where really Serverless 2.0 comes in. With Serverless 2.0, it's very similar to what we knew, a similar style and approach, but we get to run any code we want. So if you have a microservice, it's fair game. If you've got a legacy monolith, you can probably squeeze that into a function as well and have it managed. And also legacy binaries. So one of the things that's quite popular is people take a CLI and turn that into a HTTP API just by putting it in a function. And we also want that portability to run anywhere, whether that's on a private cloud, public cloud, or some sort of hybrid. And that's done through Docker containers. So where we had that zip file that was sort of failing us, this bespoke format, not particularly good engineering practice, we now have Docker images that can contain dependencies and make sure it works everywhere. And you still get to autoscale. So even if you're on premises, you can hook into your hypervisor, bring on more VM capacity. We can scale horizontally with pods. And so whilst you may be hosting this yourself, you can even run it on a platform like AWS Fargate with EKS and never touch a server, but get all these benefits. So that's Serverless 2.0. And then we have this landscape. I built this landscape up about a year ago and updated it before this presentation. The idea is that as a serverless practitioner, it all starts with a build template, right? Now, this is whether you're going along and you're copying it from the docs or SDK or generating with a CLI. There's generally some known templates that you need to use. OpenFaaS provides these. There's cloud native build packs in the CNCF. Azure Functions has its own, and they all can build to Docker images, which, remember, is that primitive we have now instead of a zip file. They then can be run on a serving runtime like OpenFaaS, Knative, or Rancher has a new project called Rio. And these are all very similar. Once they're deployed and set up, you take a Docker image and you run it. And then you get metrics, instrumentation, scale from 0, logging, etc. One of the things you then want to do is really decide where that's going to go. Is that going to be self-hosted or managed? So if it's self-hosted, we need to run that on Kubernetes, maybe on OpenShift, or on K3S, right? Basically, a Kubernetes API is what we're looking for here. Then remember that it's not just about REST. We've got events. So Cloud Events is a spec from the CNCF working group. It's now a sandbox project, and here's 1.0. And the idea here is that whilst we've decoupled the code with these Docker images, we now want to decouple the events from Amazon, from Microsoft, and from other providers, so that we can have everything the way we want it, and we have our cake and eat it. Scale from zero is something that can be really important for some customers. Live Person in Germany uses OpenFaaS, and they extend their chat with bits of code. But they don't want to have all of those functions defined by customers active at once, because they're probably not being used, right? And computers are expensive. Check your AWS bill. So what we can do is scale them down to 0, and then as soon as they're invoked, they're brought up again. That's a classic part of cloud serverless. You get it too. And then you also have the ability to have managed serverless. And so we'll talk a bit about OpenFaaS Cloud today. And these are the areas we're going to cover. All right, so that's the Serverless 2.0 landscape. OpenFaaS is a project that I founded in 2016. This is actually a community project. It's not owned by a large corporation. It's built by volunteers, and we just had our 3rd birthday. Now, there's 21,000 stars on the project and over 250 contributors, and you don't get there without sort of a compass bearing. And for us, that's been having a real focus on developer experience, having a great CLI, providing a UI out the box, loads of documentation, a Slack community, really hands-on support, and mentoring developers that want to contribute. It also has to be easy to operate so that your DevOps guys don't block it when you say we want to use this thing. So spend a lot of time making sure it's small and lightweight. And then that community centricity is kind of at the heart of a project. When there isn't VC funding and there's not millions of dollars behind it, you kind of have to lean on the community. And so that's what's got us up to where we are today. And recently, maybe in the last 2 years, we've really moved the project further and further towards Kubernetes and other CNCF projects that go well together with it. And you might remember the LAMP stack. Here's the Plonk stack. Now, the Plonk stack, as you see on the right, will typically be driven by some sort of GitOps layer. But underneath that is Prometheus that gives you metrics for auto-scaling, your dashboards, your SRE operations, Linux as a solid operating system, or Linkerd if you need something like traffic shifting. That is optional. OpenFaaS gives us a compute API, auto-scaling, and then NATS is a really nice project that gives super fast event-driven capabilities. We'll get a diagram explaining what it actually does there. And then Kubernetes, which clearly has won the orchestration war and is being adopted by 100 different ISVs that can offer you commercial support. So it's pretty much a no-brainer. Now, where normally we're looking at, should we use Flux? Should we use Argo? Should we use Knative? What Plonk is a stack not for the DevOps guys, it's a stack for developers. And we'll see what that looks like. So you've got your CKA, maybe your AD as well. And you're thinking, well, why would I need serverless on Kubernetes if I can do loads of YAML files? It turns out that actually making a microservice is quite laborious. So just say hello world. First of all, we need a file that looks a bit like this. It defines our routes. It sets a port to listen on. It defines a middleware. Pretty much this will always look the same. We then need a package JSON if we're using Node to say what our dependencies are. We need our index file for the main handler. That's where we do our echo. We then need a services YAML file, a deployment YAML file. This is a short one. They're normally a bit longer than that. We need an ingress definition, probably a cert manager certificate. We need a Docker file. Maybe we need a cluster issuer for cert manager. And I've probably missed one or two things there, right? All of that just gets you hello world. And actually, we think that it can be done a lot simpler than that, particularly if you just need a small API. And this is what you'd have for Node.js 12, the template we've got. So 10 lines of code, 5 is the handler, just a tiny bit, and everything else is still there. It's just scaffolded for you and generated. And on the right-hand side, you've got effectively what language it's using, the name, and the Docker image, because everything gets built to a Docker image, and that's it. So what would you rather manage? Have a think about it. Yes, you've got 1, you can exercise your CKAD. You've got 10, 20, 30, 40. I think it presents potentially a better option. Now, you can still get some advanced concepts here, like memory, CPU limits, annotations, secrets, environmental variables. That's all fair game, but you don't have to know about it by default. You can get productive pretty quick. This is what it would look like if you wanted to create a function in Go. And this is from the OpenFaaS homepage, just showing 5 of the templates, but actually there's dozens from the community covering stuff like Rust and C#. And effectively, this is a request and response. And then you can bring your own. So if you had a Ruby on Rails app that worked in a Docker file, and you could deploy that in Kubernetes, well, you can deploy that on OpenFaaS as well. You just have to listen on a certain HTTP port, and then you can get it managed, auto-scaled, scale to 0, the works. So remember OpenFaaS, Kubernetes, NAT streaming, Prometheus, etc. It's called the Plonk stack, where you can deploy that using our CLI installer called Arcade. It's just literally one command, and that uses a Helm chart underneath. So you'll also find a bunch of other utilities. We're considering adding Flux to Arcade as an app that can be installed. Argo CD is there. We have things like Postgres, the Kubernetes dashboard, right? And what this CLI does is it makes sensible determinations for you. If you're installing on an ARM cluster, it will switch the images. You can say whether you want a load balancer or not. So this is a really easy way to get started. And once you've deployed a function, then that Docker image, this is how it would generally work. So if we wanted to generate a statement from a bank statement, we would invoke a function via the OpenFaaS gateway. The OpenFaaS gateway will look up the function pod. It will send the request to it. In this instance, we're going to query a stored procedure, and then we're going to upload a PDF afterwards. Remember that functions don't have state, right? So we're not storing things in volumes. We're using external providers. And that's that. And then the response will come back. That's a synchronous invocation. So not a lot different from having, let's say, Nginx and Express.js behind it. Now for the URLs, you get a URL by default, which is your address / function and the name. But you can actually get some really custom examples too. If you look at the bottom of the screen, if you like a real REST looking URL, or maybe you want a .com, maybe you're running a blog or something, that is fair game too. Okay, so that's a synchronous invocation. But what if that took, I don't know, 20 seconds and we had 100 to do? You're going to be sat there for a long time waiting for those. Maybe you have to write some orchestration code to parallelize it. Not what you want to do. So instead, you can do an asynchronous invocation with NATs. Everything is still the same except for this bit. And here, what happens is the gateway, when it receives your request, it just pushes it into a queue. And then a queue worker will pull the data off and invoke the function for you. There's also the ability to send a callback URL, and then you can receive the results. Or you can have that fire off another function. And so you're kind of building a basic workflow. In this example, okay, so we've got the PDF. Now let's email it to the customers for. So this is the asynchronous version. Now, when we come to think about GitOps for functions, we still have this workflow of building a function with a template, pushing it in a Docker image, and then perhaps having it deployed and being able to execute it. You do need a Docker registry for this, so you have to store your images somewhere. And typically, the flow would look like this. You would do a push into a Git repo. The source control would fire a webhook into some code. The code would then check that out, build it, push an image somewhere. Providing the unit tests had passed, it would then go on to deploy that. And then you'd have function 1, 2, or 3 available for invocation synchronously or asynchronously. Right. And so this is the flow from OpenFaaS Cloud. But we'll have a look at this, what it looks like, and we'll also look at Flux. But I do want to show you very quickly the way that a function looks. So this is one that I made earlier. And what I have is I've pre-pulled a template. And if we look FaaS CLI template store list, this is the OpenFaaS CLI. We'll get a whole bunch coming back from the community. Things like Crystal, Vertex, Swift, COBOL. COBOL is the most recently added one, actually. And we get to look at it like this. Now, I guess I haven't tried this COBOL one, so it seems like a good opportunity to do it. Let's see. We could give it a go, actually. So let's pull that template in. And it will be put into my local folder. And I should be able to do a new language COBOL. And I put the name afterwards, hello COBOL. What we then get is that YAML file, remember the sort of 5 lines I showed you before. And along with this, we'll also get handler. And this is where you write your code. Now, I don't actually know COBOL, but you have to take my word for this one. This is reading the input that's come, and it's then going to output it. So in this example, it will either say hello world if you had no input, or it will then put what came from your HTTP request, so like hello Alex. Right? Now, I know Go a lot better than I know COBOL, and this is a slightly different template we've got, which gives you a middleware in Go. So really easy to port code over to this. And what it does is it looks for a message in your query string, and then it creates a PDF, and it basically puts whatever message you ask for in the PDF. And then when you hit the URL, it will download it for you. Right? Pretty simple. Now, this repo just has a YAML file in the root, has the name of the function, it's got this handler, and that's all I need. I'm going to deploy it using a GitOps style and on OpenFaaS Cloud. So I'm just going to make a quick change on that. Now, this is the repo where I pushed the code earlier, but it's not connected to OpenFaaS Cloud. And the workflow here is that you add a repo or organization in one shot. It's slightly different from Flux, where you're having to kind of work with the deployment keys. And so I want to look for GitOps webinar. And I'm on the GitHub app. And this is what allows it to write GitHub status is back and function logs. And let's see if we have anything to change in Git. That will do. So we'll commit this, do a push. And it's all from the IDE, right? I don't even have to have OpenFaaS or Docker locally, although you can do that too. And over on the commits page, we'll see that's been detected. It's seen that stack YAML file, the OpenFaaS manifest. It will detect the function. It will build the image, push it in a registry, and deploy it. And that's what we were looking at on the diagram. So right now, the source control has already fired the webhook. The receiver put the status there. The image is being built. If the tests pass, if it has any tests, then that will get deployed. There's the build. Go takes slightly longer than a non-compiled language. So if it's Node.js, maybe take a few seconds. This is where the Docker image is going. So that's probably on the West Coast as well. Once it's deployed, the OpenFaaS code will then go and pull the Docker image, just like a normal Kubernetes deployment, from a registry, and we'll get the endpoint. And we can see it's there. Here's all of our Docker stuff. If I look on my dashboard, this is just for me. It's got OAuth authentication. I can see the endpoint. I can see the SHA, which will match with what's on my local computer. We've got the invocation logs. We've got the build logs from here as well. So we're going to put a message here, and we'll put GitOps push or pull. Enter, and now that's gone and downloaded a PDF, right? And so in about as quick as you could manage, and with an extremely small amount of code, we've got an API that is generating PDFs for us, that is driven by a Git workflow. And every time we commit, there's an automatic continuous deployment with the continuous build, as long as a test pass. And we've got that endpoint with TLS. So that's what OpenFaaS Cloud looks like. Take a little bit more of a look at it, and I'll show you how Flux is different. So Flux tends to separate, well, it separates the CI, the build of an artifact, from the deployment of it. Generally, you want to test your artifact before deploying it, and so that's why unit tests are running the build, but there's a slightly different approach there. So OpenFaaS Cloud is one of these tools that basically is relying on a push. So a system of record, GitHub, GitLab, is pushing a webhook to your computer. You see the diagram on the right. Our code and a configuration is in one repo. That gets pushed, OpenFaaS picks it up, deploys it for you. Similar tools to this are Jenkins, GitLab. Now, one of the things that you don't get with this in the same way as something like Flux is drift control. So if somebody edits the desired state in the cluster, you'd have to wait for a build of the repo again to get back to where you were. This does tend to be a bit more efficient though, as you'll notice if you try out Flux, there's a bit of a lag. I don't know what it is, 2, 3, 4, 5 minutes before it picks up a change. But you do often need network access for this. So if I wanted to run this on my laptop, I would need to set up something like inlets as a tunnel, get me a public IP, or I would need to have access, maybe have on-premise GitLab or something like that. So this is the push style. And the opposite, well, let's get into that in a second. So this is what it would look like. We'll authorize a repo or organization. We then have integration on GitHub. We do a commit and then check the code out, build it, test it, push it, deploy it, right? And that's the flow. With OpenFaaS Cloud, there is integration, really deep integration with GitHub and GitLab. And that allows us to write those commit statuses. That's something that Flux can't do at the moment, but I think there's an open issue about looking into it. The dashboard that you have has OAuth. We're using multi-user here. What you're really looking at is a whole platform for a team, a bit like a PaaS. On your dashboard, you've got everything you need to control that. There's secret supports, governance for limits, and the ability to add teams. If you want to go a bit deeper, take a screenshot or look up this session we did with Linkerd at KubeCon. So OpenFaaS Cloud is really for managing OpenFaaS functions only, right? It's not going to manage your regular Kubernetes deployments or MongoDB or something like that for you. Now let's get to the other side. So many of you here from the Weaveworks community. When we look at Flux, we're really pushing things the other way around, right? We've got to pull instead of a push. Rather than receiving a webhook, we're pulling and polling over a continuous basis. And that's why there is that lag there. We look at the right-hand side. You have something like Jenkins in the mix still. You'll do a build, you'll push your code, you'll get a new artifact created, test it, and then update a config repository. And that config repo is what Flux will be looking at, pulling in information from there, or perhaps updating the versions in there automatically for you. Okay, so whilst OpenFaaS Cloud and the traditional approaches are pushing, this is pulling, it's polling, there's a delay, you have 2 repos instead of 1. There is some additional complexity here, right? Because you've got 2 repos now and teams have to kind of understand, as I think we might hear in the next talk, a bit about, why do I need 2 repos? You need 1 installation of Flux per repo. Why? And so there's a little bit of sort of the social side of things explaining that, but it is easier to recover from a disaster. If you're in the pool-based model and you lose your cluster, you simply will get everything back on the next pull. If you're in a push base, well, you have to wait for someone to go and do a new commit, and that might be a bit messy, unnecessary. You might have to page somebody, whereas Flux in this example, or maybe Argo, can automatically recover. And I think that's an important difference. This is a diagram that Stefan put together. Tamo mentioned that we've been collaborating for a while now. Here's a repo at the bottom of the screen. You can go through the tutorial at your own pace. And what we have here is that you would commit your code somewhere. It would be built. Flux would go and either update a config repo, or maybe it would just read from it if you're not doing automatic updates. And then we're going to apply a custom resource that is from OpenFaaS here, the function resource. The OpenFaaS operator finds the resource, and once it's been deployed, actually creates a deployment. And then we go back to that picture I showed you of the synchronous and asynchronous invocation, the gateway, everything's still the same. Okay, so this is what we'd be looking at if we're doing an invoke, or if we're using Flux. Now, we use Flux to install OpenFaaS as well as a number of the functions, which is great actually, because you could even use a mix of the push and pull. You could have OpenFaaS Cloud deployed by Flux, but your functions by the push methodology, if that suited you better. So go and check that repo. Now, this is from Stefan's instructions. Effectively, to get from 0 to Flux, you need to set up the Flux Helm chart. Here you'll say what Git repo it's looking at. Remember, this is 1 Flux per Git repo. If you've got 2 repos, 2 Fluxes, and then add the Helm Operator. And the Helm Operator will look at an object that's created by Flux in order to know what to install on your cluster. If that's a bit much, you go and look at the tutorial at your own pace, but effectively it's quite easy to set up. You then need to add a deployment key to your repo. This deployment key allows Flux access to come in and look at what's there. You can also write back. This isn't needed with other methodology, but I think this is useful. And then to deploy the chart, you write Helm release. Right, it's a custom resource that comes with the operator. And here what we're saying is I want basic authentication to be generated at the beginning. I want you to give me a load balancer so I can access the gateway, and I want you to use the operator. And that's one of the key differences for this style. Once that is applied in the cluster, either manually or by Flux, it will install OpenFaaS. Okay, actually, maybe I'll just show you that quickly. I have over here a terminal, and we can look at get Helm release, all the namespaces. We see that we've got Flux CD itself is in there. That's installed sealed secrets. We've got OpenFaaS FN with some functions, and we've got the OpenFaaS itself. You can describe the Helm release. Let's say look at the OpenFaaS one. We can actually see like what version is deployed at the moment. And if I was to go and delete the OpenFaaS namespace by accident or in production, this existing in the cluster will come and bring it back for us, which is one of the things I like about it. Now, I actually, a little bit earlier, changed from the load balancer to a node port, and this has already been deployed, and that will be in effect on the gateway service. We look at our services, we can see the gateway has been turned into a node port, right, from the default which we had. We'll take a look at a few more of the YAML files and what they do. So starting at the beginning again, you saw me create a function in COBOL. What if you want one in Go? Well, this is the generate PDF function again. So FaaS CLI can operate everything you want. It can scaffold the code. So you do new, put the language. You can build your own language packs if you want. You will then get your handler and your stack YAML, right? Build, push, deploy. And that could be useful for local testing, or FaaS up is the same deal. When you're using Flux, you doing the build and push in your CI pipeline, and the deploy bit is being done for you by Flux. But this is your workflow. Now, in order to apply what was in that stat YAML file to Kubernetes for Flux to use, we need to have a custom resource. It's just the way it works. If you're using Argo, I believe that you can execute a command line. So you could go and do FaaS CLI deploy from Argo, I believe. Somebody will have to check that. But with Flux, you can't. And so what you need to do is apply a custom resource. And this is the same thing. So we've taken everything about the language, how to build it away, and all we've got is the image name and the name of it, right? And we can get that using the generate command and the YAML file. You can also generate a CRD entry using from store. So we have like the template store, function store. There's all sorts of fun stuff in there. You can build your own functions. You can share them. This one turns black and white photos into color. And we showed it at KubeCon in 2017 with Alexis, the CEO of Weaveworks. And what we've got here is this is read in the read timeout because it takes quite a long time. Got a 60-second timeout. It's got some modes, it's got some labels, and then that will all be translated into deployments. So just to recap, this is kind of what your workflow would be like. FaaS CLI new, the language, and then the name. FaaS CLI generate gives you the output on the right-hand side. Or if you already have something like in the store, you can simply just use generate from the store. Now, when you want to deploy functions, so we looked at deploying Flux, using Flux to deploy OpenFaaS, right? When you want to deploy functions, it's slightly different. We can't just put them in a repo and hope for the best. We actually have to use Helm and this Helm Operator. And what that buys us is the ability to put in, as you can see here, these annotations. And I really like this. What you can do is you can have Flux look at the semantic versioning of the Docker image that you specified and automatically update it. So Stefan has this cert info function. It gives you certificate information on TLS. If he released 1.0.1, 1.0.2, Flux will automatically detect that. It will update this file and redeploy it. And I think that's really cool because now we have this continuous deployment for the minor patch versions, but anything bigger than that or a major release is held back and maybe we need to do something manual. You would need to set this annotation of automated to true. And again, this is one per repo. We can see this is a master branch and the path for this is the functions. Inside that Git repo, you'll see the custom resource that we talked about. So the way that we can get the image to change dynamically is by using Helm again. And this allows us to template the value and inject it. So the main difference here over the normal function CRD is just that image line, the bold one, right? Values.podinfo.image. We've also got environmental variables set here. You can see there's a read-only file system, so we're elevating the security a little bit as well. So let's go back and look at Flux again. So I mentioned that I pushed this change just before the call for the node port, and we have that in place. The other thing that we can do is I've got this create PDF function. And so we can simulate, what if we look at the output again? I think it was in, so it looks like Arial, right? Well, if we want it to look a bit more professional, we'll change the image name, go in the handler, and we'll put Times as the font instead, right? Just add the code. We don't need to use Git for this. We just do FaaS CLI up. I'm going to skip the deployment because Flux does that for us, and put the stack file. This will build an image on my computer. It's going to look at that new tag that we set for it, which has the 0.2 at the end. It's running those unit tests I talked about. Once that image is pushed up, Flux, when it is looking at the Docker Hub for this image, it will see that there's a newer one available and it will pull it in. I can't say how long that will take. It probably will be too slow for the demo. But if we look at our Helm release for functions inside the cluster, we can probably see from last time I did that. So the create PDF image went from, my original one was 0.1.0, and it automatically put it up to 0.1. And I will guess that would have done a commit into this repo as well. If we pull it back in, we might see it in the Git log. So yeah, Weaveworks has authored a change, and you can see that it made that change there. And if we look at what files it changed, we can see it changed the functions YAML, which is part of the Helm chart. So I think this is really, really useful for anybody that's doing serverless in production, and you want a way of keeping your functions up to date. You're comfortable with using tools like Helm. We can do a describe on this again. As I say, probably going to take slightly longer. Maybe by the time we're done, it will have updated. So let's go back. At least the image is up. And we'll take another look at that in a bit. All of these instructions that I'm showing you about OpenFaaS and Flux, they are in that repo from Stefan, and there'll be a link at the end if you want to go and look at it. So let's sort of see what we've covered, because there was a lot. When you're looking at Flux, this is a pull-based approach. So we're pulling. You need one repo for basically every bit of code and config that you have. So that's 2 repos. You need 1 Flux per repo or per application. There is a limited integration with GitHub and GitLab, so you can't have a commit status like I showed you, and there's no ARM support. So there's no official ARM support, and I don't know if that will be changing in the near future. There is a community-based image, but I don't like running random code off the internet. The alternative is this push-based approach with webhooks. It is harder to recover from that because you need this push in order to get back where you were. Maybe there's some kind of hybrid solution here. It is going to be one repo for your code and your config together, or you can split them if you want, but you don't have to have the separation. Tools can be shared in that instance, so you could use GitLab to do the build and the deployment according to some rules or tests. We do get the better integration on GitHub, and there is ARM support. So when you're thinking about what makes sense for you, you want to weigh up the pros and cons. There are many OpenFaaS users that like Flux and that use it. You may not want it on your laptop. You might want something else. Maybe this would be great for actually just keeping OpenFaaS up to date. So to sort of summarize, Serverless 2.0 is basically anything, anywhere, any scale because of Docker images and because of Kubernetes. If we didn't have those, we wouldn't have that standardization that lets us manage those workloads in the same way. The template store means we can reduce the duplication and maintenance. We looked at 10 lines of code instead of, I don't know how many, 400, 500 lines of text for an API. So you can move faster. OpenFaaS Cloud gives you a push approach, but it also builds an entire serverless PaaS with a Git approach. So if that's what you're looking for, take a look at OpenFaaS Cloud. If you just want to up your game and you want to recover from disasters, you want to have automatic updates of OpenFaaS itself, then look at Flux CD and Helm as the operator. This is a pull-based approach. There's a bit of a lag, but you can recover from your failures, and you can get the continuous deployment for OpenFaaS and your functions. Okay. Now, if you'd like to know more, you can connect with the OpenFaaS community. There's a blog post in the bottom right that you'll see at openfaas.com. This is the one Stefan wrote, where we integrated the operator, the CRD, and Flux. There's also an OpenFaaS workshop where you can just go through all the basics of how do the templates work, how do I set secrets, how do I do something useful with this, and then you're more than welcome to join the Slack community too. All right. So I think we'll wrap things up there. Thank you.
Oh, thank you so much. Thanks, Alex. That was quite a full talk. And in fact, we have a few questions that people have asked, and we'll get right into it. So like I said, if you're new to this WOOG, we go to the end of the hour if we go overtime, and that's where we are right now. So let's get right in there. So we had a question before we'd even started from KV. What's the difference between OpenFaaS and DigitalOcean?
Yeah, OpenFaaS is a piece of software that you can install on Kubernetes in order to create serverless functions and deploy your code. DigitalOcean is a cloud provider, much like Amazon or Google, and they can rent you servers onto which you can deploy software like Kubernetes and OpenFaaS or anything else that you need.
Excellent. And then we just got one from AJ. May I ask where OpenFaaS is getting the most traction in terms of types of customers? Are you seeing any adoption patterns such as innovators versus early adopters? That's a great question.
Yeah, it's a great question, actually. There's always been a lot of early adopters and innovators using OpenFaaS. What we noticed more recently is like more traditional companies like BT. We spoke at KubeCon with them, how they've been using it with legacy applications where they've got data scientists that just know how to code in one programming language, but don't understand any of the rest of it, and now able to sort of contribute and be part of a more modern CI workflow. Vision Bank in Paraguay also adopting OpenFaaS for their home banking service. And you're very right. I'm sure when you go into the Kubernetes world, there are many people that are still sort of struggling with monolithic applications and containers. We are seeing a mixture, but because it's a kind of, I think serverless, some people think they don't need serverless because they need to learn Docker first, then they need to learn Kubernetes, and then eventually at some point they might be ready for it. But actually, like the demo showed at the beginning, you can benefit from it already if you need some APIs or you want to work with REST.
Awesome. And we have people joining from both Zoom and YouTube. So yeah, if you guys have any questions, toward the end of your talk, Kingdon had shared that there is a release command that you can pass to Flux that would get you to the end of this demo without waiting for the poll. Maybe not for today, but he was just sharing, very helpful.
That's good to have.
Yeah, in case people want to go through what you shared. He was saying Flux Cuddle release with the -- update image flag. And then Lee was also sharing GitHub link with Flux -recv. I was seeing if maybe I'm using two computers,
yeah, so
I can't.
That's to get the bridge of the two experiences, right? So you can have some webhooks that can help out the polling so that you can speed things up. That's definitely going to be useful in development.
Yes.
Thanks for that, Lee.
Yes. Oh, just looking at, so Philip, yes, thanks for the comment. Philip and team, do you guys have any additional questions? Oh, here we go. Vic Vicus is asking, can you talk a bit about NATs?
Yeah, so actually spoke about NATs and how it links into OpenFaaS quite recently last week at NATS Connect, and there's a video recording you can go and find. Nice. I've probably shared it on Twitter. But basically, NATS is a very fast message bus, and it's a CNCF project too. The company behind it, Synadia, just released a 2.0 release with loads of fun stuff to go and check out. We're doing a bit of work with their team at the moment to improve the support in OpenFaaS. And yeah, it's great for PubSub. You can also use it for queuing. I think, Tamar, you mentioned RabbitMQ earlier. So you can do that kind of thing too.
Cool. And then on YouTube, we have Andre asking, do you have any examples with GraphQL?
I do not. I'm not a GraphQL practitioner. However, you can consume a GraphQL API like the GitHub API very easily from a function. You can just call it with the SDK. I'd have to look into it as to whether you could make a function return GraphQL. But why don't you try it? Let us know.
Just commenting that I worked with GraphQL in the early days, and you could at a minimum set up the proper REST RPC endpoints for the function, and then the Apollo libraries or whatever GraphQL server you want to set up in your function would definitely work. You probably want to pick something that has a low runtime overhead, or try to figure out how to run the GraphQL server process in the background.
Yeah, I guess I wasn't sure what it used behind the scenes, but if it's a HTTP server, then that goes back to that Ruby on Rails comment I made, that you can really take a Ruby on Rails, potentially even WordPress, put it in a container, deploy it through the OpenFaaS API or through this or through Flux. As long as it conforms to the serverless definition you can find in the docs, you can invoke it. You can set a custom like run up time if you're doing machine learning. So there was something that we've put out recently today. Particularly machine learning takes a long time to load the image at the beginning. So you can add a custom delay. We're also looking at taints and tolerations through a profiles feature, and actually looking for contributors. So if anybody's interested and wants to get involved, there's some fun stuff to do.
Excellent. We're kind of at the end, but I'll take one last in from Denny. Thanks for joining. Where are the BSD-based examples? OpenFaaS has so many BSD builders, but BSD isn't mentioned at all in the docs of OpenFaaS. Is OpenFaaS Linux-based?
What is BSD? Like Beta, Sierra, Delta, and BSD.
Yeah, BSD is a alternative
operating system
Unix.
and a license. What's that got to do with? Sorry, I don't get the question.
Do you want to articulate a little bit more, Denny? Blaze is adding it's a different distro.
I can't see the original question. I know what FreeBSD is, but I don't understand the question.
I was curious.
Kubernetes doesn't work on FreeBSD, quote unquote. There might be some hacks and VM things you can do, but basically Kubernetes is for Linux, which is why the Plonk stack has an L in it. You can probably add a Windows node into OpenFaaS as well. I mean, that's come into Kubernetes recently. We did do that with Swarm actually in 2016. It was quite fun. But there wasn't anything at the time other than .NET 3.5 that you wanted to run on Windows that you couldn't run on Linux.
Yes, and he's confirming he was mentioning FreeBSD. He was just doing shorthand, but yes, no problem, Denny.
Nice. Yes. Well, there's quite a bit in that presentation, so I want to sort of show you the options and why serverless might be interesting on Kubernetes. I'll make the slides available afterwards, and I guess we'll have a recording for people too, right?
Yes, yeah. So for any of you who come for the first time, we always post these on our Weaveworks YouTube channel. So if you've joined by Zoom, you will get an email from me, and we have all the links and all the information. If you've joined by YouTube and you'd like the information, you can email gitops@weave.works. That's probably the best way. I'll put it in here. And thanks, Alex. This was great. Turned into a full session. That's our email address. And thanks for everybody who joined through Zoom and YouTube. So we will continue on. We are very lucky to have Javeria Khan from Palo Alto Networks, who will be chatting with us about her journey with GitOps and have great tips. So it'll be sort of partly a presentation icebreaker, and then partly we'll go into a conversation. So we'd love to have a conversation. Love to have a conversation with all of you and include all of you. So we'll have a very brief break, and then we'll be right into that. So thanks for joining from all over the world, and we'll see you just in a few minutes. Thanks, Alex.
Thanks again.
I think Stacy might have some music she's going to.
I'm going to try it, and then you can tell me if it actually comes through.
Yes. So,
all right, so let me know if you can hear this.
yes. So
I can turn up the volume.
Join later. We have Daniel Hallback on our team, who also DJs. He's a community manager, and since it's late in Berlin, he gave us a recording that we've been using for music that we've been using for these GitOps days.
Can you hear that?
I can't hear anything.
Can you hear that?
No.
Nothing. Okay.
Yes, we
it
had
might not work through the Zoom function.
Yes.
Just because of the capabilities of Zoom are a little bit limited, unfortunately.
Yes. We were using OBS, but had to move off because they were creating delays on YouTube. We weren't sure. Maybe now your bandwidth is better, but it's okay.
It's good to have a practice session like this. We can learn how to do it for next time.
Yes, that's why hopefully you guys know, as we mentioned, these are practice sessions that we're leading up to. So like so many people moving their events online. So we're practicing all these different platforms. So yeah, if any of you are experts and have feedback, we'd love to hear all your thoughts. Or if you just have feedback as attendees, we welcome any of it. So with that, Alex, are you going to take off? Are you going to hang out? It's up to you. I know it's late for you.
Yeah, it's 7 o'clock, so I think I'm going to go get my dinner.
Yes,
I
sounds
might
like a
drop
good
in
idea.
again later.
All right.
Yeah.
Thanks so much for
Good to see you
joining.
all. Okay.
We'll see you next time. Bye-bye.
Thanks, Alex.
All right. So with that, why don't we switch over to Javeria? We'll pipe in our own music. Lee can do some singing. But yes, hopefully you guys had just a minute to go get some water or do a bathroom break. And yeah, why don't we, Javeria, if you're ready, why don't we just dive into having a conversation with you? So thanks so much for joining.
Of course. Can everybody hear me fine?
Yes, I can hear you. Yeah.
Okay.
And
get those slides shared.
Sure. And we say you're from Palo Alto Networks. Are you actually in Palo Alto as well?
Yes, I also live in Palo Alto.
Oh, that's nice. So you have a short commute if and when you go back to the office.
No, actually, so the office is in Santa Clara. I'm not quite sure why they named the company that. Actually, nobody.
Really? So it was never based in Palo Alto?
No.
Oh, so interesting. Yeah. Who knows? Maybe
the networks were just in Palo Alto.
Yeah, exactly. Or maybe somebody else already had Santa Clara Networks, so they couldn't name it that. Oh, interesting. Okay, so you got to commute over to Santa Clara. Cool. So yeah, we were just chatting offline beforehand. So you're cool with we kind of have a presentation, which is really nice. And then
it's a bit short. I'm just trying to figure out how to share the screen.
Yes. There's a green button that says share screen. So yeah, and in fact, you're preparing a presentation is well beyond anything we were expecting. We were just going to have a little chat, but it'd be great. Yeah, great to know a bit more about your journey. And so that way we can have more of a structured Q&A session, which will be kind of ongoing. So while we're waiting for you, I was going to ask people, we've gotten some great chats of people sharing where they're from, but also, yeah, I'd love to hear who's already using some form of GitOps. I'll start bothering some people who've already been chatting either in Zoom and or YouTube. We had a couple of new people, which was fun to hear. Ooh, Utrecht, very cool. I'll bother you.
Oh, I think I need to join back again to allow security settings. So be right back.
No problem. I'll use this chance to do a little chat. I was actually curious. I don't know if I've asked Denny. One person says, I wish. Well, so this is perfect. If you join in later, I was sharing how we'll be doing this GitOps Days event May 20th and 21st. You'll all be notified of this. And part of it is if you're really excited about GitOps, like about having trouble convincing your management or convincing other teams, that's the event we're trying to help people with that. So yeah, let us know. Some people have shared either their challenges or their successes at finally getting management to understand the value for them as well. Like Lee and I had the fortune of being at a company where it just so happened one of the engineers was doing a Flux training in live at that moment. So we got to join and hear how people were sharing and getting people on board with different open source technologies. So yeah, we'd love to hear. Let us know.
All right,
Cool.
I'm already.
Excellent. You're ready to go. Oops. I'll hand it over to you, Javeria.
Okay. Well, hi everyone. Thank you for joining us today. My name is Javeria Khan, and today I'm going to talk a bit about my GitOps journey. Firstly, me just sort of introduce myself. I'm an electrical engineer by degree, and I started off my career as a hardware engineer. I then switched over to software a little over 6 years ago. Over these last few years in software, I've worked in multiple infrastructure teams. So everything from DevOps to systems and as the industry now likes to call it SRE. But generally the focus is basically always about building infrastructure for reliability, automation, operability, and performance. At this moment right now, I am an SRE at Palo Alto Networks in the foundational infrastructure team. I lead our on-premises Kubernetes infrastructure. So my team basically serves as like a foundation layer that spans multiple organizations within our company. And we build and we manage everything related to on-prem Kubernetes computational infrastructure. Main part of our responsibilities is, of course, our Kubernetes infrastructure. All the clusters that we manage, these run on bare metal nodes across various data centers in the world. I lead the building and the scaling of these production and staging clusters, and also support infrastructure building with a special focus on obviously using GitOps to aid developer productivity and to sort of help with infrastructure scaling. So before I get into like the details of the tools that I've used with the architecture or the design decisions, let me just briefly get started with GitOps itself and sort of define what we're talking about here. So what does it mean to use GitOps? As by now, hopefully everybody already probably knows that GitOps, the term itself was coined by the people at Weaveworks here some couple of years. But it has since then gained much more popularity with many tools now in the cloud native landscape offering automation around operations and dev processes. But generally, in essence, the idea is that you version control both your infrastructure and your code, and then you can use a GitOps tool to compare the current state of your objects in your cluster or your infrastructure to the desired state you have in version control. So this way, by automating the deployment of any kind of cluster changes, you gain, first of all, robust reversibility because rollbacks are easier. You obviously have the previous version source control somewhere. And then secondly, you gain an audit trail, which is nice because everything goes through PRs and you know who did what at what time. And lastly, teams gain transparency, which is the most important. And this is nice because now there are no more obscure system layer changes that only one special admin person knows how to do. So besides the benefits of gaining transparency and reversibility that I just mentioned, in my own personal journey, I've been working with Kubernetes for the past 3 years or so. And over this time, I've built many clusters on the cloud as well as in data centers on bare metal nodes. And every time you go through that process, where you design a new cluster, whether it's for staging or production, doesn't really matter. As engineers, we tend to sort of end up looking into how to optimize those processes and how to automate those repetitive tasks and how to make managing those infrastructures that you keep building less painful. This is where GitOps has really helped me automate some of these otherwise painful management tasks. And I think it also brings better collaboration between all the different types of teams that eventually end up sharing these resources. So using some of these tools that I mentioned later can really help augment the entire software development and deployment lifecycle. So when you introduce GitOps practices and tools into your infrastructure, let me just briefly sort of define what it could look like and what steps it can actually help you at. So to begin with, obviously the developers do their pre-pod development on their laptops and their testing on their laptops. And then they can use some kind of image building tools or app development tools to build that source code into containerized applications running either directly on the laptop or in any remote dev clusters. This is assuming that the apps that they're building are intended for containerized applications, obviously. So some of these tools can actually help automate this process by iteratively syncing their local changes to the repo or also to the remote containerized applications running in staging clusters, for example. They can also aid further integrated testing by providing port forwarding to those remotely running dev or staging apps. And they can sometimes also stream those logs back for them. So when all of this is done and tested, and when the developers are done with their local testing, they can then push this code up into production branches of code repos for PRs. And then the CI system, whichever you choose to use here, can build this code again, build and test it for you again within its pipelines, and eventually push these newly built images up to a private or Docker registry or whichever you prefer to use at this point. Now, once those new images are available on the registry, you can have GitOps controllers such as Flux running inside the Kubernetes clusters, watching those registries for new images. And as soon as new cluster app images are seen, it can automatically apply them to your cluster seamlessly. So similarly, system level configs such as Kubernetes manifests or deployments or services or load balancers or ingresses, they can also be source controlled in separate repos. And I like to call these config repos. And you can have separate controllers or basically the same controllers also watching these config repos. And as soon as it sees new changes within your deployment specs, it can apply them to your cluster as well. And as soon as you merge changes to those repos, it can apply them there as well. So the other good thing here is that auditing process I talked about. Whenever somebody needs to do a change in the cluster, it will automatically go through a PR process, and somebody will approve them, obviously, and then it gets merged. And then as soon as they get merged, your clusters can update their config that way. So I began my GitOps journey at my previous position at Branch. Branch is a mobile deep linking and attribution platform company. They were an early adopter of Kubernetes, and this is where actually I started my whole Kubernetes experience as well. So what happened was we had a couple of self-managed clusters in AWS, and it was at the point when we went from a single production staging cluster to a few more that it actually started getting harder to keep all of them in sync. And this was especially true for deployments that ran in multiple clusters at the same time. So you might, obviously, you do that for load balancing reasons, or you do that for HA or disaster recovery where you want stuff in multiple regions at the same time. So while we had automated our CI/CD pipelines, we were using Circle CI to deploy new code versions to all intended clusters at the same time. There was still the problem of keeping the deployment specs in sync. So things like the resource requests on individual deployments, or the replica counts, like how many pods each of those applications run in different versions of clusters. And obviously, most importantly, the image itself that it was running. So And even more critically, we obviously had the odd issues where one deployment could go out of sync with the rest because somebody accidentally modified the image it was using, or they were testing something and then they forgot to revert back to the previous version. So while these kind of one-offs were easier to manage in single clusters, they quickly became a nightmare in multiple ones. The talk around GitOps at the time was just beginning. I was just starting to hear about it. And that was when I decided to give Flux a try in our infra and to see if it would help solve these operational issues. It was pretty successful. I would say it solved a majority of the issues we had here. So the way we did that was, since our CI/CD pipelines were already automated to deploy directly to the clusters, and we were using the cloud version of Circle CI. So they did this by pushing new images to the registry and then updating the deployments directly on the clusters to kubectl. So one other problem here is also the security aspect of it, because basically if you're using something outside of your cluster to deploy inside of it, you have to open a few security group rules, for example, and to allow that external entity to sort of get access into your cluster, and you're giving it edit access actually. And this is obviously much more concerning for production clusters. So the CI systems were basically connecting to the clusters every time to deploy a new application. And but once we introduced Flux, the CI pipelines were simply changed to update the image in another config repo that was keeping the cluster deployment YAMLs. So they sort of, within the CI, they would create a new PR for the config repo and update the image spec over there. And they stopped, and we didn't have to have the CI touching the cluster every time anymore. These later config repos were the ones then Flux that was running inside the cluster was hooked up to, and it was watching. And the good thing about this process is that the CI system now doesn't need to be given access to your cluster. And then also you don't necessarily have to run your CI inside of your infra as well, which is obviously the better way to do it. But still, even if you do that, and even if you have your CI within your cluster or within your infra, it still becomes more complex as you have that single CI system that's managing multiple deployment destinations or multiple deployment clusters at the same time. And lastly, outside of Kubernetes, I know I keep talking about Kubernetes because this is where GitOps is more popular at the moment, but since the ideology here is that you're version controlling everything, you're version controlling your config, the actual stuff that makes up your infrastructure, all the components, and then you're also version controlling the stuff that runs on top of it, which is the applications. So you can use this literally anywhere. An example here is that, for example, for Prometheus config changes, we had a few things that we had homegrown solutions for, which is what I would like to also categorize as GitOps. So the example here is the Prometheus config changes, which we also started keeping in a repo for Prometheus config repo stuff. And we created client agents that ran on the prom server that watched this config repo for prom for changes, and then used a prom tool to validate new ones as soon as it saw them before applying them to the server. This right here is a really good example of improving collaboration between teams as you scale, because as you get more teams that are given their own individual infrastructures, they're given their own clusters, for example, or their own namespaces. And they have their own applications with their own sort of monitoring streams or alert manager rules. And you want them to manage those rules themselves, and you don't necessarily want them waking up the admins at 2 a.m. when they have a harmless but noisy alert going off and they want to update it. So what they can do is just push PRs to that config repo, merge them, and that would update their alerts for them. All right, and then next, as I moved over to GitOps, move over to Palo Alto Networks. The difference here is that the infra here is obviously much larger and it's much more dispersed. For Kubernetes itself, we have about 40 on-prem clusters. This is a mixture of production, staging, more production, obviously. Clusters running on bare metal nodes in our various data centers across the world, like I mentioned before. We also have new clusters being created in GK for all the applications that we've moved to the cloud. So the main idea here is that as we move towards managing more and more hybrid infrastructure, that is both cloud and data center at the same time. We found ourselves moving towards tools and methods that support and work well in both environments, and that make it easier to manage everything in centralized repositories. It's obviously been a trial and error here in certain things. Also because, like I described about my team earlier, since we're the foundational platform, we service multiple other teams inside the org, and we provide the core infrastructure and the tooling. So GitOps allows us to coordinate more smoothly across all of these multiple internal SRE and dev teams, and then they can share that orchestration and config management tooling. But coming to the structure itself, I sort of break it up into 3 main groups. So generally we do GitOps at 3 layers here at Palo Alto Networks. First of all is our Kubernetes infrastructure. So the older Kubernetes clusters here that we've had for a while are all configured and managed through CI/CD in Jenkins and GitLab. We maintain the state of these clusters in version-controlled Ansible playbooks. So basically, all the infrastructure code for building these clusters, such as for all the cluster components, such as the kubelet, etcd, CNI, as well as any add-ons for observability or extra features. These are all kept as Ansible templates, which we use to build, maintain, and upgrade our clusters. We have separate repos for these, obviously. Everything here, all the changes for updates or component updates, for example, if you're bumping up the Docker version or if you're moving to a new version of etcd, everything goes through PR processes, everything goes through that approval process before deployment to any QA or prod environment. And these Ansible playbooks were actually an internally managed distribution, and this is how it's been done here for a while. I've recently moved our new generation of clusters to use the upstream kube spray based deployments instead, where we use that to build a cluster for a major part, and then all the extra add-ons and configurations such as exporters or logging or metric collection agents that you might want to run, those we do through our internal templates, to our internal Ansible templates that we keep in the Ansible repos. So I'm moving these internal Ansible repos as well, Ansible-based components, to use Flux so they can get updated automatically without needing somebody on my team to apply them every time. So this is where it would actually be helpful. What happened before was that people would actually, every time we did push new changes, or for example, I'm doing cluster logging through Fluentd and I have a daemon set running everywhere, and I have my configs kept in the Ansible templates for that deployment. If I need to change the config for a particular cluster, if I wanted to ignore certain type of logs, or if I wanted to ignore certain type of namespaces, somebody actually has to go and run those playbooks manually. Putting Flux here would be really beneficial, because then as soon as somebody merged those changes, they wouldn't need any of us to apply them. So also, as I mentioned GK earlier, our newer platforms are all being deployed to GK clusters with separate GitLab pipelines running in GCP, and we manage that separately. Over here in the Kubernetes domain, all our deployment CD pipelines are configured to use Vault, Helm, and there's an internal fact management system that pulls in all the secrets and server information for deployments during builds. So all of that is automated on that side. And then secondly, coming to the next layer that we apply GitOps at. This is for everything that runs on top of the clusters, which is the applications. So all the Kubernetes application manifests, such as deployment, secrets, services for individual applications, they are maintained in separate Git repos as Helm charts. And we build new app images. So the code is built into new app images within their CI pipelines. And then we deploy these to the clusters as actually new Helm releases. At this point, I'm also looking into adding Flux as a part of the last GitOps cycle, so that for the application layer, which is obviously a convergence tool, and it can continuously try and keep the state in the cluster in sync with the version you have defined in source control. And very lastly, outside of Kubernetes, like I mentioned, GitOps is sort of universal in the sense, even outside of Kubernetes, this is where we use it as well. So we use GitOps to manage all of our GCP infra through version control Terraform scripts that are applied through PRs in Atlantis pipelines. So Atlantis is basically also, I would categorize as a GitOps tool because when somebody merges those kinds of changes to your repo, it can apply those templates for you. This is good because it allows all of our multiple SRE infra dev teams to build out projects and internal components on demand and in predetermined ways, with the review and approval process stage being handled within those PRs. So sometimes if they're requesting new projects, for example, if they're requesting new access changes, and if that needs to go through InfoSec, they can have those approval things done within the PR. And obviously it's going through Git, so everything is tracked and there's an audit trail over there. So we know what changes when and who requested what at what time. For all of our on-prem stuff, which is provisioning, orchestration, config management, this is all done through version control Salt. This is run as schedule states, and we use a bit of Terraform here as well. The monitoring and alerting for all the on-prem clusters is also kept in separate repos, similar to what we did at Branch. We keep the alert manager scripts and their rules and their runbooks in the same repo. And these also get applied automatically by SIG jobs running on the global Prometheus servers. The Kubernetes cluster logging itself uses Fluentd, like I just mentioned. This is also kept in Ansible templates, and it's managed likewise and released likewise through PRs and approvals. So there's a lot of tools here at the moment. I mean, GitOps has been around for, I think, about, I would say, 3-ish years now, and it's at a much more mature state. And Cloud Native has a bunch of these tools that can help you in different stages of everything. And now a lot of them have common features, but they're not exactly interchangeable. I usually like to sort of categorize them into 3 main layers. The innermost layer, I think, are templating tools like Helm or Customize. These help define your apps, and they make it easier to roll out different versions for different clusters. A layer above this would be the app development tools such as Draft or GitCube or Scaffold. These help building of an application up to running it in Kubernetes. So these are sort of meant to target like inner workflows when the developers are still testing their applications. And very lastly is the deployment tools like Flux or Argo are the ones that you are meant to use in production, and they help keep things in sync with the source control you have in Git. However, the most important traits, I think, are, first of all, ease of use. So how many things is it making you install or learn? And very important is that, is there a community, and how easy is it to get support for it? So we've already talked about Flux quite a bit already. Then there is Draft by Microsoft Azure. It's a tool for developing apps as it targets that inner workflow of a developer. And this is meant to be used before code is committed to source control. Then there is Scaffold. I like this one a lot. It's actually a very well-rounded tool. This is by the GCP people. It handles everything from building to pushing to deploying your applications and also syncing it. And then secondly, most importantly, also is how stable is that tool, and is it recommended to be used in production environments or not? So Flux and Argo, obviously, when here, I've used it in production for a while. I think it works well. It's easy, it's lightweight. There are certain things I wish it had when I started using it. Most of these I see have been addressed by Flagger later. I haven't had a chance to really test that tool, but at the time, some of the features I wish it had at that point were, for example, it can watch your images and it can apply them automatically to your cluster. But what happens if there's a bad build and you're rolling that out in production? So it would have been ideal if it could sort of watch those rolled out apps and trigger a rollback if any issues were seen using a cluster monitoring tool like Prometheus. We ended up building a homegrown solution for this. So similar to what Flagger does now, after the CI system pushes those images. It sort of watched the Prometheus endpoints for the specific stats that we were looking at, and if their error rates were within, if they were reasonable, or if it wasn't spitting out too many errors, it was fine. If not, it would roll that back for you. And the main advantage here is that you sort of mitigate downtime for potentially bad builds. For the time it would take for somebody to notice that something was wrong, they got the alert, they would triage, they would debug, and then they would realize something needed to be rolled back. The second thing was there at the time there wasn't any support for blue greens or canaries. We did those at branch a lot because we have a lot of production services and many number of pods servicing those, and you don't want to roll everything out at the same time. You sometimes want to do a gradual rollout. So those features were important there. So this is my very last slide. But we've talked about structures, we've talked about the kind of tools that you can possibly use. But how do you bring about these changes, especially in environments where people are already used to doing things in a certain way? They already have processes in place. At this point, I would say collaboration between the dev and the ops teams is very important for a successful GitOps culture. So over time, I've learned that the biggest hurdle in introducing any kind of new processes is trying to convince people to take out time to learn and to adopt to it. Even when it's like meant to eventually optimize their daily workflows, engineers can sometimes still be short-sighted about the taking out the initial time to learn and to also change their current workflows. So I guess as operators, what we can do is we can try to keep the delta on their end as minimal as possible. So the ideal here is obviously push button operations. So for example, if I take the Flux example and rolling that out, it sort of just took developers a bit of time to realize that any changes that they did live on the clusters would get reverted back like immediately within another minute or two. And they had to learn that there were processes where they would have to disable that deployment for automatic syncing and then update to whatever they were trying to do. And then we would enable it back. Also, we had to sort of just socialize how pushing PRs and updating those config repos was important. People were not supposed to touch the cluster anymore for bumping up memory resources for pods, for example, and they weren't supposed to do any of those kinds of changes. So those are for the dev layer things. For management, the other main point to convince teams to adopt, I think, is by socializing how their dependency on admins will decrease. So with GitOps tools, the changes in infra can roll out and roll back through Git merges. So that's automatic. And that way, you don't necessarily need to go ping that main admin on vacation or at 2 a.m., which is usually the case in startups, to roll out special changes or to roll back a broken build. And in extension, which is important as I was talking about management, I think a main attraction for the management level folks is that you also get to reduce the dependency on single employees who have all that special infra knowledge. We sort of refer to this as the bus factor informally. So this was basically it from my side.
Cool. Thank you so much. Yeah, I have so many questions, but we also have questions from the audience, so we'll jump in right there. Blaze was asking, oops, let me scroll back up. It was, do you have suggestions for defining SLOs from scratch? And also an additive, I'm hanging out in the Kubernetes SIG instrumentation and we need a lot of help. Any thoughts there?
Defining SLAs from scratch, in my experience, that's always been more of a management layer thing where managers defined how those metrics should be collected and how they should be defined. So I think a good way to approach that would be perhaps, well, the way to collect that would be Prometheus and things like monitoring tools where you could collect those stats and you could see how long your uptimes were or what the responses would be like, for example.
By the way, Blaze was adding earlier that right toward the beginning of your session, like this is a godsend for me. I'm building a cluster on my home lab as we speak. So really appreciate this. So it's great to hear that. Any other questions? While we're waiting for you to post questions in either Zoom or YouTube, Lee, I was curious if you had any comments or thoughts.
Yeah, I have quite a few comments. Thanks so much, Javeria, for going through so much in-depth information about the detailed environment. This is a pretty incredible environment. Do you what's it like to work and like have so much intimate knowledge over something so large?
So I guess over time, as I switched over into software and then switched over to this domain, I think this is what attracted me most to it. Instead of going like deep into like one layer, we sort of have to touch so many. So you have to know like a bit about everything. What is it like working with it? It's it swings between frustrating and rewarding at times, obviously, because it's large and it's dispersed and it's had many owners over time.
Mm-hmm.
So basically what happens is every time you have a new owner that comes in or somebody that leads it, we bring our own best practices that we've learned over time. So things slightly shift. So we were building clusters in a different way before, we're building them differently now. There's trade-offs, but I sort of took certain decisions because I see them better for the long term. So I guess, yeah. Mm-hmm. I think what's important here is having healthy conversations and not necessarily taking these or necessarily not rolling out changes like these by yourself. So some things like GitOps that are going to directly affect the devs or the people that are using this stuff, it's important to talk to them about it before. That's where the collaboration comes in. You have the before rolling out something that's so drastic that changes people's sort of idea of how they usually interact with these environments, and you have to sort of socialize with them how it's going to change, but how it's going to improve their life for them. And if they have any feedback, then incorporating that into your design as well.
Yeah, I can imagine that it's like when you're trying to own a platform, right, and it's so wide and broad, like you constantly are having to deal with drift of the endeared like practices that you have and that other people have adopted and used to really get their job function done, right, and collaborate with their team. You have these endeared practices, and then you have the aspirational ones, right, which is like, well, I mean, these things like really cause this problem, right? Or like when you were trying to deploy the logging changes with Ansible, right, and it's got like this practice in there that is, it has a bus factor,
right,
and it's a very ornate kind of operation, you know, that ties you into that tooling and into those processes. Have you been, is there a story about recreating things, like as you refactor processes and move to more modern things? Like, do you, some of those old clusters, have you refurbished them to newer processes or management? It can be really difficult to like retrofit
like
when something is stood up.
Yeah, for a much larger, so this isn't hugely large, I would call it sort of medium scale here at Palo Alto, but with those 40 clusters that we have, some of them have been around for a while. And now we have different scaling needs and we have different feature requirements. And sometimes also it's understandable from like the operator point of view. A lot of people, once they build something, they don't want to touch it. So upgrades are hard. We have them pinned to certain older Kubernetes versions. So that's where, when we decided to roll out newer versions, because it was addressing many issues. For example, we wanted new features. We wanted to be able to use newer Kubernetes versions. We also wanted to be able to support other features on top of it. And then we had other scale requirements. That's where you decide, okay, so this is how we've been doing it so far. Does it make sense to keep doing it this way, or should we change it? So change is important, but it's also a bit disruptive because now people have to learn how to do things that way. And I'd say it isn't a clear-cut sort of move over. Well, for example, where we were using our own internal distribution to build out these clusters, and then we moved towards using an open source tool now at the moment. So it isn't a complete cutover. So we are using the open source tool, but we're still using a bit of our old internal templates as well, because we have some very specific components or configs that we use in our environments, and they need to be kept that way. So I would say it's a trade-off. There's always a bit of a tug of war between the devs and the operators into how they want things. There's obviously multiple stakeholders. So you just have to sort of reach that compromise between all the different teams, management and dev and ops. And it isn't possible to make everybody happy, but you have to sort of move forward that way. So I would say we aren't completely deprecating our older clusters. The ideal is that we move over to new clusters, and we're slowly going to move our applications to the newer clusters this way. But at the moment, we're sort of, we're still maintaining both of them at the same time, both of the infrastructures.
Cool. Well, we have tons of questions. We'd love to get into that. And many people with all caps saying how awesome this talk is. They're finding it very helpful. So thanks for all your feedback, everybody. So the first one is, oops, I have to scroll back up. There's so many, it's filling up the chat. So one was, I'm sorry, it just scrolled. So I gotta go back to where it was.
Yeah, there's
Okay.
questions. I have so many other things that I'm curious about and want to ask, but like let's
Okay,
definitely get to some
here we
of
go.
these.
So first essay, would you lean towards Helm CD operator with Flux or using plain YAMLs for Kubernetes ops config like ingress, cluster roles, etc.? What's your guidance on that?
I found just using Flux with plain YAMLs is much simpler. It's also smaller of a delta sort of to socialize with everybody. Helm is great. It's got lots of bells and whistles. You can do stuff much more in a complicated way, but sometimes Helm can get too complicated, especially as your apps grow and they're more and the definitions become larger. So like you have multiple clusters and they all have different, for example, specific configs that need to get applied. So they point to different, so that application points to different endpoints in each cluster. Helm is good for that kind of stuff because it can sort of reach into your fact management systems and it can pull down the values that it needs. So this is how we do it right now, basically. So we have Helm charts and they're sort of generalized for everything, but depending on the cluster that you're applying to, it can go and it can pull out those changes and apply them to you for that specific cluster with those specific values in those variable files. So, so definitely Flux and simple YAMLs if your use case is simple, but Helm can be helpful if it gets more complicated, but it's obviously there's a bit of more management needed on that side.
Cool. Another one saying, excellent presentation. I can imagine how a startup like Branch would be a fan of GitOps. Could you please speak a bit regarding who and how GitOps was championed at Palo Alto Networks even before you got there? That's an interesting question. Also, is a lot of this forward thinking driven from bottoms up? Even when you talk about collaboration between dev and ops, or maybe the opposite, from the top down.
Bottom up, I assume you mean people at our level and then going up to management.
That's what I'm guessing.
I think
yeah.
That's usually how it is because we're the ones that are sort of knee deep into this work, and management is more, they're more concerned with the SLAs, like somebody asked earlier, and making sure that things are running at the same time. So they have sort of a bird's eye view and they have a higher level of visibility. And you're the one that needs to decide that, okay, we can attain these goals better by introducing GitOps practices. I think the person asked, how did I champion? Oh, so before I joined Palo Alto Networks, as far as I'm aware, there was no, it wasn't focusedly called GitOps is what they thought they were doing. But as I mentioned before, GitOps itself is like, it's a more generic term. It's not just Kubernetes. So they already had all this infrastructure in place, for example, for the Prometheus configurations, where the global servers have agents running and they have their own repos for the alert management rules and they get applied automatically. So all of that structure was already built by the infra engineers and it was already there. So I think these ideas have been in the industry for a while now, since we've all moved to these sort of cloud and shared infrastructures where you don't want just only specific people managing it and having all the knowledge, and you also want version control. So you don't want sort of having to go to those specific people to get their changes applied. So Prometheus was a good example. You're keeping all the alert manager rules and repos together. Obviously, as you cycle through employees as well as team members. So everybody who joins at a later date doesn't have to necessarily go and ask different people for access. They know where the code is, they know how to change it, they know how to apply those changes. Did I address, I mean, sorry, there was a few points to that question. I may have forgotten one.
Yeah, I think you answered, because the question was there already some groundwork in place at Palo Alto Networks before you joined? So I think you addressed that. And Vincent asked sort of a similar question about, was there a change management involved in either company from somehow legacy to GitOps, or was it pretty smooth? If there was some change management, how did the companies deal with it? It's great because you have these two different examples that's really helpful.
So since Branch is a startup, I would say it was much easier there. We had a much more smaller and robust team. When we decided to bring about these changes, we had sort of tried them in staging for a while, and I thought they would look nice and it was a good way to move forward. It was basically just about sort of, I think, scheduling a meeting and then just sort of taking everybody through it. So explaining what the new workflows would be like and telling them this is how we would be changing them. I think we socialized stuff through some Slack messages as well, just sort of giving people an overview of, okay, this is how we're changing it. This is how stuff is going to look now. So it was easier over there. Over here, it wasn't hard as well, still, because my team owns all of that infrastructure. So the deal about building clusters and deciding how to build them was still in our ownership. So all I basically had to do was sort of socialize the idea before. There were certain issues that we had with the current ones. They weren't scaling, or they had other issues and they were old. And in certain cases, because it is the data center, some of the hardware was old, we wanted to move over to new stuff. So we already had all these issues that we were trying to address. And then that's where the conversations around, okay, so we're going to rebuild this. And then that's where we started talking about, okay, so there's a better way to build this now. Let's stop maintaining our own distribution internally, because that's a big overhead. The team isn't that large. You can't have people maintaining your own distribution when open source does it so well already. So let's take what's already there. Let's take the community version that's already well maintained. They have patches and they have security releases, and they regularly update their stuff that way. So let's take that portion. And then also let's keep stuff that's working well for us internally. I mean, let's not completely throw that away. So that's where sort of that mixture comes in. It was about having a few conversations with the team, with like the managers. Everybody was on board, so it wasn't hard. It was just about doing, obviously you test pilot the stuff first, so you build it in like one location, and you sort of compare with what you have, and you sort of do that on trial basis. People liked what they saw, and it just went forward from there.
Nice. I could see, I mean, definitely know examples where there are more challenges, and one person does share. I often see senior architects who have no idea about Git trying to pull, I guess, hit the brakes to eliminate GitOps, as they think of it as something that would create breaks and would break itself. It's extremely difficult to troubleshoot, they also think. And I guess the quote is, if you touch it every day, chances of catching, there'd be the chances of catching wrong stuff. Sorry, I'm trying my best to read this. Yeah, so I guess you're kind of on the fortunate side. You haven't really encountered these types of individuals, I guess, the people, and and I don't think they're bad people. They're people who come from so many different, we, like I said in the beginning, we talk to so many people who have different backgrounds. They have different technological journeys to go through, and I think there's also just a concern with change, right? Something that's unknown, or feeling unsure about certain terminology.
Well, to be honest, I mean, myself included, as you spend more time in the industry, you kind of become more averse to change, because you've seen it break so many times, you've been through so many incidents. Sometimes you think the best idea is to sort of, if something works, not to touch it.
Yeah.
But for a lot of these places, because the main environments I work with is Kubernetes for the past few years, anybody adopting Kubernetes is already adopting the bleeding edge stuff anyway. So they're looking at the new tooling, and they're trying to bring about the new ways of doing stuff. Otherwise, you can just run your applications on bare metal servers themselves. Now that's a separate discussion. Sort of convincing teams that are used to sort of running their applications directly on servers to move to Kubernetes. That's where I would think people would have issues having these conversations. We've had a few of these. It isn't so much as an aversion to new tooling or thinking that it's break. It's just, like I mentioned earlier, it's just the overhead for them to sort of take out time to learn it. So everybody's already so busy with the stuff that they need to do right now. They just need to be convinced to sort of take out like maybe that half an hour a day, or like an hour, to show them this is time well spent, because in the future this will save you so much more time, and this will be much more resilient. It'll be much more available.
Yeah. There's also a question, does Palo Alto Networks use GitOps with Twistlock? Or maybe just a bigger, what's your security solution?
I don't know. So I don't interact with the Twistlock team. I'm not sure. I mean, we do provide the foundational infrastructure for them, but since they came through an acquisition, they have their own infrastructure at the moment.
I see. Cool. Are there any other questions? We're getting toward the end, but Lee, I know I kind of jumped in. Did you have others on your list that?
Yeah, I'm actually curious. With regard to, you mentioned, Javeria, the blue-green kind of operator with rollback, or you have a solution that, was that running outside the cluster? Is it inside the cluster? Or
That was within the CI. So I see Flagger addresses all of this, but this is a relatively new tool. I've just sort of
Yes,
been
it's very
taking our
new.
time to give it
Yeah.
a spin. But what we did at the time was, since our CI was already automated to roll out the deployments to the cluster, because they touched the cluster and they would do like a kubectl set image and they would update the deployment. So within the CI, that's where we had those extra tooling scripts which would watch that deployment and watch the metrics that they exposed for like maybe the next 5 minutes. And we would see if the metrics that it was exposing were still within a reasonable range, as in there weren't too many errors or there weren't too many 500s being thrown out. We would say this is successful, and then it could move over to the next one during the canary. So it was all baked within the CI system.
This was at branch, you mentioned?
This was at branch, yes.
Yeah. Okay, cool. Yeah, it's an interesting need that often has to be built before we kind of got to this place where now we have tools like Flagger, and there are a few others that have similar interfaces that are now providing this kind of declarative way to get that behavior. It's really interesting.
Definitely.
I found it interesting as well that you listed the event-based rollbacks as kind of this separate item, and it made me think that, like, outside of the context of the deployment, are there policies that you might want to write that could potentially do, it's hard to argue, you know, that something would be deployment related, you know, 10 hours from now. Do you have thoughts about that?
So that's something that would be very use case specific. At the moment, I can't really imagine how somebody would go about making a generic tool for the community for that. But for like our use case, definitely same thing. So if certain events were going wrong, or if you saw, so you rolled out something, but it was fine at the time. But then, for example, your traffic scaled up somehow by some X, and you saw that your application started dying. And you decided that maybe the previous version was better, and that's what it should, because the newer version had some scale fixes that weren't behaving as expected. So maybe something that was watching those kinds of endpoints, your traffic or your eventual sort of metric systems. If you're AWS, it might be, or Stackdriver and GCP or whatever. Yeah. And then depending on those systems, and if it could tie into them, and then roll back your applications for that kind of stuff.
Yeah, you wouldn't just be looking at error rates, you'd be looking at performance and traffic and doing some kind of like anomaly detection.
It could be anything. Yeah. I mean, any kind of metrics that you expose.
Yeah, that gets into some pretty web scale type operations kind of thing.
Yes, that sounds about it. Yeah.
Very cool. And then, gosh, I was going to ask about one more thing, but I can't remember anymore. Well, thank you so much.
Yeah. Well, while you're thinking about it, I was going to share, I put in the chat, and I'll share with everybody and with you. We have this GitOps hands-on that uses Flux and Flagger. So if you want this encapsulated way to do a canary deployment using Flagger, it's something that Stefan, the creator of Flagger, also made, and we've been putting out there. In fact, Lee did a whole in-person one at our last community special, where we said, well, let's try this. We'll walk people through it. And we actually got people to the end, because, you know, that could be a challenge to actually walk people through an actual hands-on, but that was definitely fun. So I'll share that with you as well, if you just want to get a taste of Flagger. So yeah, we are at the end. We have AJ saying thanks. This is an excellent meetup. I think nice balance between solution and speaking. Oh, well, thanks for all the great comments. Really appreciate it. Yes, although we did miss Daniel's music. Sorry, Vincent. We will make sure we bring that next time.
I was going to try again at the end to see if I could get it right. But
yeah, I was thinking that if you shared your screen and it was playing music, maybe that would be
actually, it's an option, yeah, that I was researching. So
yes, we're very fortunate that, you know, there are a lot of DJs out there part-time, but we actually have a great one. Of course, we're going to say that. So with that, thank you so much, everybody, for sticking out for this very long session. Both if you stuck around for both Alex and Javeria, and really thank you so much, Javeria, for jumping in and sharing these great stories. I'll be bothering you again about our GitOps days. If you haven't seen her before, she spoke about GitOps with a coworker at Branch at KubeCon a couple of years ago about that use case. And then we invited her to a GitOps panel that I organized for the last KubeCon in San Diego, right? That feels like such a long time ago. Trying to put our pieces together. The last KubeCon that ever existed so far, we could say.
And we used to go outside, yes.
Yes, in person. That was lots of fun because we had Javeria on a panel with other people sharing their stories as well. So it was really nice to hear different technologies and different perspectives. So really appreciate your joining, and I'll definitely be talking to you about some future talks because it's really great to hear everybody's feedback. And yes, you covered so many of those things that I said we want to address at our the final event on May 20th and 22nd. So thank you. And thanks, Lee, for joining in with all your great questions, and everybody else. And thanks for Stacy for organizing. And we'll see you at the next one next week, another practice session. Appreciate it.
And I'm going to try the music now as we fade out, okay?
As we
you let me know
out.
if you can hear it.
Just for Vincent.
Can you hear
Yes,
that?
Here
it is.
Is there a screen that you can put on?
I don't know. It's not. There's no screen really right now. So if I was in OBS, I think I could. But is the music too loud, or?
It is a bit loud.
Okay.
Let me share my final slide. Actually. Oh, I can't share my slide while you're.
Because I'm sharing the computer sound. Yeah. I can stop though. I was just testing to see if that would work, so that's good. Let me stop sharing and then you can finish it out.
Good test. As I said, we're practice running. Cool. Well, thanks everybody, and thanks Javeria again. I'll see you guys next time.
Thanks everyone.
Bye.
Bye.